Hello, my name is Joseph Dewey, and this short video is in regards to breadboarding. Breadboarding is a low-cost method of prototyping electronic circuits. The type of circuits that you usually will breadboard is something that's of relatively low voltage, low current, and low frequency. This here is a section of breadboard. I believe it has 800 or so tie points, and each hole in the breadboard is considered a tie point. And the way it's laid out is this top row here is all one connection. So this point here is the same as this point here, is the same as this point here. The next row down works on the same principle. A connection here is the same as a connection here, same as a connection here. But there is no physical connection between these 2 points. Further down, we'll see these columns. And these columns are, this point here is equivalent to this point here. There's no connection from this column to that column. They're separate. There's a channel or a groove in the middle of the breadboard which isolates the mirrored portion of it. So again, this point is the same as this point, and these connections are the same as these to those. Okay? Get a better idea or understanding of, flip the breadboard over, and you'll see the metal parts that make the physical connection. And as I said, the top and bottom, there are 2 rows. You see here, it's one continuous metal strip. There's a break, and another continuous metal strip. So this point would be the same as here, but there's no connection from this contact to that contact. Again, same thing with the columns. You see the individual columns, and there's isolation between both those columns. In terms of the isolation for this, it's just a simple piece of plastic. Again, these things are not meant for high voltages or high currents. You would not want to connect 120 volts across these points or these points. Also, since the plastic is relatively small, again, you would not want to be passing any high currents through here. I would be very nervous of anything over 750 milliamps or close to 1 amp. Over time, I've seen the plastic on these things melt with high current and high powers. So again, very low current, low power, again for the hobbyist. The actual connections on the breadboard are like this. As you can see in these columns, this metal tab is embedded into the breadboard, and it has 5 fingers in it representing the 5 holes. It's kind of hard to see, but if you take an edge-on look, you'll see how they come together and touch at the top. So that's the actual connection as I showed earlier here and conversely here. Again, as you can see, not much metal to it, so definitely not a high power connection. So usually with these style of breadboards, you would need some sort of wires. And sometimes you purchase a breadboard and it'll come with a wiring kit with pre-cut, pre-measured wires. You can also buy unsundering wire packs that have these pre-made connections. Already these are about 4 inches long, they're 6 inches long, 8-inch long sections. Or you can just, get plain wire itself, cut it to the correct size that you want. That's the user's privilege. Next, I'll show you how to go about wiring a circuit into a breadboard. The next part of breadboarding is starting out with a good schematic of the circuit that you're going to prototype. By far, this is the most important part of breadboarding. And a good schematic will show you the pin numbers of the IC that you may be using. Also label the components. This circuit here is just a basic inverting amplifier with a gain of -2. I'm not going to bother with the electronics and how it does it. This exercise is in how you would breadboard this circuit. And like I says, I have all the pin numbers labeled. Also, I call out for the power supplies, plus 5 volts and minus 5 volts, hooked up to pin 7 and 4 respectively. Ground for the positive input of the op amp. I've labeled my components, my two resistors, and what their values are. An input terminal and an output terminal. So the next thing is, let's start the breadboarding process. Here's my breadboard, and this is the exact same one as earlier, except this one's mounted on a backer plate with terminals brought out so you can jump her from the breadboard to the terminal to come up with a heavier connection. First thing I'm going to install is my IC, and it's hard to see, but there is a pin, a little notch in it at one end, and that will represent where pin 1 is. So in all actuality, this first pin here is pin 1. I'm going to plug that into my breadboard. Notice how I've straddled the channel in the breadboard. So these set of pins are on one side, these set of pins are on the other side. And again, this pin here is this whole connection there, that pin there is this whole connection there. The next thing to wire up would be the power supplies. And what I usually do is there is a color code to it, and if you follow the National Electric Code, any positive power supply, in this case my plus 5 volts, should be wired with a red wire. And I took some red wire, and I cut it myself to the proper length. So I'm going to plug that into my breadboard. And you can see I went from the top row to pin 7 as called out of my schematic, right there. And actually one more thing I'll go over. This being pin 1, so that's pin 1, 2, 3, 4, 5, 6, 7, 8. So it goes around in a counterclockwise fashion for the numbering. The next pin I'm going to wire up will be the negative supply. And National Electric Code says a negative power supply should be labeled wired with a black wire. And that goes from pin 4 to the ground, the negative terminal. There we go. And again, there's pin 4, and that is connected to the negative or bottom rail of my breadboard. And the last wire I'll put in is the ground terminal, and that's being used to ground the positive input pin 3 of the op amp. Again, pressing that wire in. So now I have pin 3 wired. So I have taken care of pin 3, pin 7, and pin 4. Now I want to install these components here. I'm going to take my 10K resistor, and it goes from an input terminal to pin 2 of the op amp. And usually, I'll use a needle nose pliers, bend over the leads to make it nice and neat. And that goes to pin 2, so I'll take one leg of that, plug it into pin 2 of my circuit, and the other leg will be off in space. So now I have my resistor going from pin 2 to this point here, which will be my input terminal. I'm going to bend it slightly out of the way. Okay. The next component that has to go in is my feedback resistor, 22K. Same thing, I'm going to bend the lead. It's over. Nice and neat. And with that, I'm actually going to straddle the IC. So I'm going to go from pin 2 over to pin 6. Sometimes it can be difficult to get these wires into the hole. So a needle nose plier will be helpful. Okay, so now I have that. I'm going to bend that out of the way too. So I've pretty much have completed the circuit diagram. My feedback resistor going from pin 2 across the IC to pin 6. And next, this is where I would use some of the store-bought connections. Take one wire, plug it there for my input, and then I'll take another wire, plug that in for my output. So the input would go to a waveform generator or some signal, and the output would either go to a DMM or an oscilloscope. So that's pretty much a breadboard wiring technique that I use. And like I said, the key thing is knowing where your power supplies are and neat, careful wiring. I hope you find that helpful. And in a later video, I'm going to go through testing this circuit here and seeing how it works. Thank you.